everyone, it's Steph from Eastern Regional Libraries here. We're going to do a few science experiments today. Most of them are going to be around water. We're going to find out some interesting stuff about water and how it behaves. So what I thought we'd start with today is an experiment using a glass of water and your finger. And all we need to do is stick your finger in the water. So see if you can feel that. You can feel the wet water all on your finger. But what happens if we get some cinnamon and we put that on top of our water? Let's have a look. We'll open this up here. I'm just going to pour some all on top of the water there. Can you see that floating on top of our water? Oh, there's lots on there now. Let's spread that out so we've got a nice layer of cinnamon over the top of our water here. And then we're going to take your finger again. You might dry it off and then stick it back into your water. If you take your finger out, you should see there's no water on your finger. Your finger is completely dry. You can stick it right in. Let's see, can you see my finger in there? Reaching down into the water. It's still completely dry. So what's happening? How does the cinnamon help to keep your finger dry? Well, our cinnamon is really hydrophobic, which means it doesn't mix very well with the water at all. And because the two things together are not mixing together, they want to keep apart from each other. Our water, with the surface tension, it holds all together and clings to itself. So it doesn't want to mix with the cinnamon. It wants to hold itself together, just water. So what it does is we've got our surface tension working and our cinnamon helps to hold the surface tension of the water together so that when we press down, it doesn't break through. We don't break the surface tension of the water. So we can't actually get through to the water. It's like a bit of a film on the top that we can't break through, and it keeps our finger nice and dry. So what about other things that float? We know that pepper floats. So I thought today we might try and see if the same thing happens when we try pepper. So let's pour a bit of pepper on top of our water here. Get a nice layer across the top there. You see it floating all on the top. You see a few bits starting to drop down though. So I wonder if this will be different. Let's find out. Come have a look and we'll see what happens. So you can see it was a bit different with our pepper. Look, that's mixed in with our water a little bit more than the cinnamon did. So it hasn't kept my finger quite as dry. We've got a bit of water on there. So maybe at home you can have a play around with some different things. Try out the cinnamon one on the top. It's really quite cool to be able to stick your finger into the water without it getting wet at all. But yeah, have a try with some different things. Try some pepper, maybe try some other things that float. See what works for you and what doesn't. Okay, so for our next experiment, we need to definitely make sure that you have a grown-up around to help you with this one because we're going to be using a little bit of fire. But all you need is a candle on a plate, and I've just stuck a little bit of blue tack on the bottom of the plate there to get the candle to stand up nice and straight and tall. And what we're going to do is get a little bit of water and just pour a little bit of water onto the plate here. So just a little bit on there, got a little bit of spill, that's okay. And we need another glass as well. So a glass to go over the top of your candle and sit nice and flat on the plate. Get a nice good seal with the water and the plate there. So let's light our candle. There we go. And then all we need to do is get our glass here, turn that upside down and sit that over the top of our candle and make sure it's right in on the water. Got a good seal down to the plate there. And let's watch what happens. So it didn't show up so well with using this glass. So I'm going to try a different glass, a bit of a taller, thinner glass. So let's try it again. We're going to light our candle up again. I've put a little bit more water onto our plate as well, so that hopefully it will make it a bit easier to see what happens. So we'll light our candle. And then let's just see if we put this glass over the top, sit that right over into the water. Watch our candle and our water level. Let's see if we can see what happens. Did you see the water level rise just after the candle went out there? See that water rising up into the glass there. Okay, let's give this another go, see if we can have a good look at what's going on. So, we've got our candle here, we're gonna light it up. And we've got our glass here, we're gonna sit that over the top. See if you can see where the water level is at. Did you see the water rise there just after the candle went out? Have a look at where that water level is now. So let's talk about what's going on here and why this happens. So when we've got our candle alight, it's heating up all the gases and all the air that's inside the glass. And what happens with the gases and air when it's heated? Just like water, it'll expand. So we've got lots of expansion going on inside the glass, and that creates a lot of pressure inside there. And so there's high pressure inside the glass when the candle is lit, and that's sort of pushing down on the water, keeping that water low. But once our candle goes out, the heat isn't there anymore. So a lot of the gas and the air inside there actually contracts and gets sort of smaller inside there. So then what we have is low pressure inside the glass and high pressure outside the glass. So what happens is we don't like to have a low pressure and a high pressure. We want everything to be equal. So all our water gets pushed from outside the glass into the glass, and you can see that water rise when the candle goes out. And so that means that all the air inside is now an equal pressure to the air outside. Okay, so we're gonna do an experiment and try and see if we can do a bit of ice fishing. So we need some ice. We're gonna grab a few bits of ice. Quite a few bits in our glass here. And then we're gonna add a little bit of water as well. So a little bit in the bottom here. So you can see we've got about halfway up our glass there with water and our ice on top as well. And then we need some string for our fishing line so that we can go fishing for our ice. Okay, so cut a piece of your string for your fishing line about this long, and let's see if we just dip that in onto our ice there. Let's see, do you think we'll be able to pick up any ice? No, it's not working, can't get any ice. So, but what we're gonna do is sit our piece of string, our fishing line, in on our ice there, and then we're going to sprinkle a bit of salt on top. So let's just do a little sprinkle on there, and then we're going to let that sit for about 1 minute and see what happens with our string and our ice. Okay, so let's see if we lift up our fishing line now, if we can get any ice. Oh, nearly. So it broke off there. It was stuck to our ice, but it just pulled away. I think we need to try that maybe one more time. Let's see. Okay, let's try that again. We got so close that time. We nearly caught ourselves some ice. So let's sprinkle a little bit of salt back on the top of our ice. Just a nice little sprinkle. There we go. All right, and we're going to give that another minute and see if we can catch ourselves some ice this time. Okay, so we've let that sit a little while. Let's see this time if we lift up our fishing rod, lift up our string. Let's see if we can get any ice. Oh, can you see that? Look at that. We have caught ourselves a big block of ice. Can you see that string sticking to the ice there? Lifting that up out. Okay, so what's happening? Why does adding the salt help us catch our ice better? Well, salt, when we add it to ice, actually lowers the ice's melting temperature. So what happens is it actually melts some of that ice, but then because we've got the water and the rest of the ice in there, it's still quite cold, so it actually refreezes, and it freezes around our string and sticks it to our ice so that when we lift it up, it stays stuck to the string. Okay, so for this experiment, you can see we need 2 big jugs of water. We've also got 2 smaller containers. We've got these 2 here. And I've actually grabbed a few rocks from outside as well, which we're going to put in our smaller containers to weigh them down, make sure they sit right in the bottom of our larger containers here. So we'll pop a couple of rocks in here. And what we're going to do is put some hot water in one of our containers and some cold water in our other one. So let's start with our hot water. I've boiled the kettle but let it cool for a little bit so it's not too hot. And let's pour that into here. And then we've got some icy water over here. We've got our ice here. It's a bit melted. We're going to pour some of that into here and we'll let some of the ice go in as well. And then we might top that up with a bit more cold water. Okay. And we're going to add some food color as well so that we know which is our cold one, which is our hot one. So for cold, we're going to put some blue in. Let's drop some blue into the cold water. Mix that around a bit. And some red for our hot water. Let's mix some drops in there for that one. Stir that around a bit. Okay, so we're going to put our cold water into our big jug here and then our hot water into our other big jug here. And I want you to tell me what you think is going to happen when we drop those in. So we've got our cold water. You can see it's got quite a big open top here, whereas our hot water, it's got a bit of a smaller top. It goes a bit in here so that it's nice and small. You can see that there. So which one do you think is going to escape faster? Which one do you think the water is going to mix together with our water in our jugs? What's going to happen? Which is going to go faster? Have a think. What do you think will happen? Let's give it a go, shall we? We're going to drop both of these in here. So we're going to get them right down to the bottom. Can you see the hot water rushing right up out of the container there? There's that hot water and you can see it all coming right up to the top, sitting right on top there. You might be able to see the colour sitting on top of the water and then the clear water down the bottom. Whereas our blue, you can see it's mixed in a bit. Some of it, I think, with the ice escaping has mixed it around a bit as well. But we've got most of our dark blue water still sitting down in our jug here. Sitting right down low there. Whereas our hot water, it actually works a bit like a volcano. Our hot water rushes up, pushes right up to the top, and you can see it sitting on top of that colder water there. It's all gone out, sitting right on top there now. So it's not really actually mixing together. So that's just what happens in our oceans. When you have hotter water, it rushes out, it moves around more, and it sits on top of our cold water, which is a bit denser because it's colder and it sits down lower. And this can actually happen in the ocean, that we can have tunnels of cold water, currents of cold water running through the ocean. And what we've found is that sound, because it moves a lot better in denser areas, it can move quite a long way through these cold tunnels of water. And some scientists actually think that whales can use these tunnels of cold water to communicate with one another through long tracts of water in the ocean. Thanks for joining me today and checking out our science experiments. I hope that you'll try some of these for yourself at home and change up the variables. So what I mean by that is try different temperatures, try different containers, different amounts of things, and see what happens and how the experiments change when you do them a bit differently. And have a guess and see if you can work out why it is that these experiments are a bit different when you use different elements in them. But I hope you've enjoyed our videos today. Thank you again for joining me, and I hope we'll see you again soon.